Today we will be going over chapter 13, which is how to control microbial growth. So on this slide it just gives you kind of an idea of where we see microbes growing. Again, the reason why they don't grow on the steering wheel is because your hand rolls over the steering wheel and wipes off the microbes. So although you are touching the steering wheel a lot, because you are wiping the steering wheel with your hand, that causes the microbes to fall off. So a large volume of growth occurs on the center console, as you can see here down at the bottom, and that center console has food typically spilled on it, which is why there's a lot of microbes that grow there. So, and you don't wipe off that area with your hand typically. What to take from this is to remember a fomite is an inanimate object that can harbor microorganisms. Okay, so classification of infectious agents and biosafety levels. So 1 is the lowest in terms of danger to humans, minimal risk here, BSL-1. BSL-4 is the highest risk here. Thing to remember is that exotic disease is a disease derived from a foreign location. Those are typically the most dangerous diseases for humans because we have not been exposed to them because they are from somewhere else. Therefore, we don't have immune protections against them like antibodies. So these are some technical terms that you need to know. I'm not going to go over those right now because I feel like you can just memorize those. Okay, so canning. So Clostridium botulinum. Remember, Clostridium strains can produce spores. Botulinum is one that produces a neurotoxin that causes paralysis and can stop respiratory function. This is also one that you need to know what the toxin is later on in the course. It grows very well in canned food because it's a low oxygen environment. Therefore, we take the can, we heat it in steam. Typically, it goes up to 121 degrees for 2.5 minutes, and then it is sealed. The cans are then, outside of the cans are then sterilized as well, and this creates a sterile environment where the can is thought to only contain up to the maximum of 1 microbe per can. And that's why you have an expiration date on your cans, is because if there is 1 microbe left behind, it's not a sterile technique. It just reduces the microbial load. That's why you have a expiration date on your cans. So some more terms. Do know what's the difference between disinfection, sanitization, and sterilization. So sterilization is eliminating all the cells, endospores, and viruses. So there's no microbial load there. Sanitization reduces, and then disinfection reduces or destroys. And so things like dishwashing is a sanitization process because the dishwasher sprays water and detergent, detergent can kill the microbe, but the spraying of the water then brushes the microbe off, so you reduce the microbial load. So a disinfection, however, is cleaning with a chemical, and that chemical is known to kill microbes. Microbial death, there is, the difference between bactericide and bacteriostatic. Bactericide is like suicide, it kills the microbe. Bacteriostatic stops the microbe from growing. So a viricide and a fungicide would then kill viruses and funguses. Sorry. And fungistatic would mean that you stop the fungi from growing. The key thing to know here is the decimal reduction time is the time to kill 90% of a population. So the shorter the DRT, the quicker you're killing 90% of the population. The longer the DRT, the longer it takes to kill 90% of the population. But remember, you must always think of what is the concentration of the chemical being used, right? And so this is why, like for instance, bleaches are between 5 and 8%, because if you go above that, the fumes become toxic to humans. So an autoclave, the key thing here is 121 degrees at 15 psi, which is a pressure, for 30 minutes. So what this machine does is it combines heat in the chamber with steam being blown in at a pressure, and that heat plus pressure kills microorganisms. And this is for sterilization. So you destroy everything inside of an autoclave except for prions. the viruses, bacteria, and fungus, they all get destroyed in an autoclave. So typically most of the time we are not in contact with prions unless it is a person that's been infected by prions in a hospital setting. So autoclave sterilization is for bacteria, viruses, and eukaryotic pathogens. Pasteurization. So take your milk, heat it up to 72 degrees Celsius, which is pretty hot, for 15 seconds, and then you bottle it. It does not remove all microbes. However, it removes enough microbes that you can then keep that milk on a shelf at a low temperature for a certain period of time, which is why you have an expiration date on your milk. Now, ultra high temperature pasteurization, this is different. It's going to be heated to a higher degree, and that is going to kill more microbes in that period of time. So then if you ever looked at UHT milks, ultra high temperature pasteurization milks, these milks tend to be good for up to 3 months from what I've seen on the shelves, because there is a higher level of pasteurization, a higher level of microbes killed during that pasteurization. Some people will say because of that higher temperature, you denature more proteins in the milk, which makes it taste different. So some people do not like that. So refrigeration and freezing. So when you bring the temperature down from 37 degrees Celsius, which is what our body temperatures are and what most pathogens to us like to grow at, when you reduce that temperature, that reduction in temperature makes the microbes grow slower because it's a non-optimal temperature. Obviously, the lower you go, you slow the growth even more. Below 2 degrees Celsius can kill some microorganisms. Our typical household freezer is 20 degrees Celsius. I'm sorry, refrigerator is 20 degrees Celsius, and our freezers are 4 degrees Celsius, so we don't get below 0 degrees Celsius. There are minus 80 degrees Celsius freezers in labs, and that means you've essentially bacteriostatic for those microorganisms. Desiccation, removing the water, adding salts, that creates a hypertonic environment that causes the water to leave the cells of the pathogens, which then they